on page 136. We're doing a word problem. So, we're going to try solving this word problem. It says, the height of a football kick from the ground is given by the function h at t. Okay, we're going to write down this function right now. T squared plus 20t. In this function, they're telling us that h represents the height of something, and t is equal to the time. So they told us that this function represents some guy kicking a football off of the ground. He kicks the ball. This function represents how high the ball is in reference to time. That's why we have height and time in this question. Okay? I want you guys to find the x-intercepts and kind of relate them to real life. So right now we're in standard form, even though we really don't have a c value. I do have a b value and an a value. So assume the c value is like a 0, okay? We don't have to write that in. We just assume the c is 0, so we know we're in standard form. I'll get rid of that. I need to factor this. I need to put this in factored form in order to graph this quickly. So what that means is I need to find a common factor first. Okay. So, height and time. We need to factor this in order to graph this quickly. So, common factors. I can quickly look at this. I know that -5 and t. I can take out -5 and t from both of these. So, in other words, I'm going to divide each of the terms in here by -5t. -5t. Okay? When I do that, I'm going to be left with -5t on the outside, if you guys remember. And then what I divide it by on the inside of this bracket. So -5t squared divided by -5t is just t. And positive 20t divided by -5t is going to be -4. So my height and time in factored form is this. This is equal to -5t times t minus 4. So, okay, just keep going. I need to find my x-intercepts. In order to find the x-intercepts, if you guys remember, we set our y, or in this case, it's represented by h at t. In the other equation, it was f at x. They're going to give us different variables every time. We're going to be setting the left side of the equation. Think of it like that, equal to 0, to find the x-intercepts. So, find our x-intercepts, we set h at t equal to 0. It's equal to -5t, t minus 4. Okay? Once again, even though there's only one set of brackets, still think of this as a separate number and a separate number. Okay? We're going to split our equation again, and we're going to set those two numbers equal to 0 and solve for the variables. So, one of the equations is going to become 0 equals -5t. The other equation is going to be 0 equals t minus 4. Okay? So I now have two separate equations. We'll call this equation 1 and equation 2. So we have our two separate equations. I need to solve for t. Well, in the first number, I got to isolate t, so I divide this side by -5, and I divide 0 by -5. I still get 0. So t is equal to 0. We're going to make sense of that in a second. That's one of them. The other one, I move the 4 to the other side. I end up with 4 is equal to t. Okay? So I have my x1 and x2, we're going to call it, okay? Or, in this case, t1 and t2. So the two times. Now remember, what we're trying to find is our x-intercepts. So let's get a graph out here. Okay, so my t at 0 and my t at 4. So remember, this question was talking about some guy kicking a football and the equation representing the height of the ball in reference to time. So our X-intercepts were 0 and 4. So that means 0 and 4. I'm going to try to make sense of this now in reference to my equation. So this guy was kicking the ball from the ground. It makes sense that when time is 0, so before he started, the ball was on the ground. As soon as he kicks it, time will start moving. Okay? That's what we're doing this question in reference to time. So as soon as time started moving, we know that something happened to the ball. It starts going up, and then eventually after 4 seconds, it hits the ground again. So our X-intercepts are representing when the ball is touching the ground. When he first kicked it, at 0, when time was 0. And then after 4 seconds, it hits the ground again. That is amazing hang time, by the way. You can make the NFL with that. Okay? So, we know our parabola is going to be something like that. We don't know how high it goes yet, but it's going to look something like what I've done there in red. We'll get rid of that now, though. Okay, so now that we have our X-intercepts, 0 and 4, I'm just going to quickly change the t's to x's just so we can make sense to our axis of symmetry. So remember, one of the x's is 0. We solved that over here. And one of the x's is 4. That's what these t's were representing. Our equation was x1 and x2. x1 plus x2 divided by 2 gives us our x value for the axis of symmetry. Okay? We'll make sense of that in a second. So our x1 is 0. Our x2 is 4. 0 and 4 divided by 2. This is going to become 4 over 2 is equal to our x value, which means 2. X is equal to 2. Our axis of symmetry is always going to be exactly in between our x-axes. So actually, by looking at this, we could have probably eyeballed it. Between 0 and 4, the midpoint is going to be 2. We plugged it into our equation, and we found out that the midpoint is 2. That's the axis of symmetry. So I know that the axis of symmetry, or a mirror line for this, student blue, is going to be at 2. I know the axis of symmetry is going to go something like this. Okay? Or not something like that. It's going to go up and down that line. X is equal to 2. That's the axis of symmetry. The middle of our parabola. So I know that this parabola is going to change directions. I don't know how high it's going to go yet. But at 2, it's going to change direction and start coming down. So what that means is when I kicked this ball, it was increasing in height for the first 2 seconds. Once it hit the 2-second point, it stopped and started coming down again. Okay? That's the axis of symmetry. I don't know how high it went yet, but the parabola is going to look something like that. Get rid of that red part. Okay, last part of this question is the maximum. Okay? Maximum or minimum. What that's talking about is the vertex of our question. So once I found the axis of symmetry, I can find the vertex. In fact, this is one of the points of the vertex. This is the x value. My axis of symmetry, wherever my vertex is going to be, I'm assuming it's somewhere in there. It's going to be x is 2. I just have to find out what y is. Once I find out the y, I'll have the actual coordinate of the vertex. Okay? So what that means is because I have the x value, I can go up please, to our original equation. Okay? Or even our factored form. It's up to you, whichever one you want to work with, because our factored form and our standard form are the exact same equation. We've just rearranged them. To make things simple, I'm going to go up to our original equation, negative 5t squared plus 20t. Okay? I can plug in this value. So h at t is equal to negative 5t squared plus 20t. Okay? We know that the vertex is when t is equal to 2. That was our axis of symmetry. So I'm going to plug that in. I'm going to plug in h at 2 to find the coordinate of the vertex, the y value. So I plug this number 2. That's what we found here. We know it's the first coordinate of our vertex. We're plugging into the equation for our t. So it becomes negative 5, 2 squared plus 20 times 2. Okay? So I'm plugging the number 2 in for t. I'm replacing t with 2. Now all I have to do is solve for the rest of this equation. This becomes negative 5 times 4 plus 40 becomes negative 20 plus 40, 20. Okay? So that means the vertex is at 2 and 20. I didn't draw this quite to scale. Let's say this is 4, 8, 12, 16, and 20 instead, okay? So change the scale a little of this graph. My black line wasn't even right there either. I can get rid of that. No, not what I want to do. Just get rid of this here. Okay? Change the scale of this line so it makes sense here. 4, 8, 12, 16, and 20. Okay. So, according to this, when t is 0, the ball is at 0. We know it's the X-Intercepts. At 2 seconds, it's reaching its peak of 20 feet or 20 meters in the air. Not sure which one it is. Could be 20 kilometers. I doubt that for 4 seconds, though. We know that the vertex of this parabola is 2 and 20. That's why we need to find the axis of symmetry. Once we found the axis of symmetry, it's also the x value for the vertex. So we knew that it was 2. The axis of symmetry was x is 2. We plugged that 2, if you guys notice, into this equation here. And we found that the y value was 20. So the height, the maximum height of this parabola is 20. Now the reason this is a maximum is because the parabola is pointing downwards, okay? We assume it keeps going. If it's a downwards pointing parabola, it has a maximum. If it is an upwards pointing parabola, it has a minimum, okay? The vertex will be at the lowest point of that parabola. For homework, guys, obviously you have those questions I've already put in your blue notebook. So if you turn to page 143 in your blue notebook, it has all the questions there. But since we're going to try to split this lesson probably, so I've already given you 8, 11, 15, 16. From page 140 in your textbook. If I write in blue, it's your blue notebook. If I write in black, it's your textbook. Okay, guys? I want to add a few questions to it. So, actually, just deal with number 8 and 11 for now. And I'm going to add question 2 and parts of 10. This is getting confusing. This is what's going to be your homework. Question 2 from that page. Question 8, 10, except for the y-intercept. So if you look at question number 10, it's a table. You guys should be able to find everything except the y-intercept. I haven't shown you how to do that yet. So we'll say minus y-intercept, okay? So get that down. And table 13. Table 13 will be great too. Yeah, sure.